Welcome to AI Reads We Learn playlist, where we will pick security blogs and use AI to learn and read these blogs. Today is day 1 and we will be covering a blog which is about first malicious MCP server. It talks about a postmark backdoor that steals your emails. Now let's dig into this blog and AI will help me learn about it. Let's get started.
We all trust our tools, right? Especially the smart ones, our AI assistants that are supposed to make our lives easier. But what happens when one of those tools, one you rely on every day, quietly turns against you? What if it becomes a spy in your own system? Well, that's exactly what we're talking about today. This is the wild story of the world's first malicious AI tool of its kind found in the wild and how it completely betrayed thousands of people. And get this, at its peak, this one rogue tool was stealing up to 15,000 emails. And I'm not talking about per month or even per week. No, this was happening every single day. I mean, think about what's in your email. Password resets, confidential memos, invoices. Literally everything was being siphoned off.
So this whole thing, it really brings up a terrifying question, doesn't it? Could the very tools we use to be more productive actually be the source of a massive, silent data breach? And maybe the scarier part is, if they were, how would you even know?
Look, this isn't some what-if scenario. This actually happened. It's a real-world incident, and it all revolves around a specific package called Postmark MCP. This is the story of how a tool that looked totally legit ended up betraying thousands of developers.
So, to really get why this was such a big deal, you've got to understand how much people trusted this thing. This wasn't some sketchy, obscure package you'd find in a dark corner of the internet. Oh no, this was a staple. It was being downloaded 1,500 times a week, every single week. People relied on it, they recommended it. It was basically part of the furniture, as trusted as your morning coffee.
And the developer behind it all? Well, on the surface, he looked like the perfect professional. We're talking a software engineer from Paris using his real name with a super active GitHub profile just packed with legit-looking projects. But that was all a facade. Behind the scenes, he was impersonating an official package and just totally abusing everyone's trust. A real digital Dr. Jekyll and Mr. Hyde situation. So how did he actually pull this off? You might be picturing some super complex, sophisticated hack, right? Well, you'd be wrong. The real genius, if you can call it that, of this whole heist was just how simple it was. It was way more about social engineering and just being patient than it was about any kind of technical magic. It all came down to a pretty classic 3-phase attack. Phase 1, build trust. And he was patient. For 15, count 'em, 15 straight versions, the tool worked perfectly. It became part of people's trusted infrastructure. Then came phase 2, the switch. With version 1.0.16, he slips in one single hidden line of malicious code. And boom, phase 3, the harvest. The backdoor flips on and the data just starts pouring out. Simple, patient, and absolutely devastating. And here's the crazy part. This entire operation, this whole betrayal, it all hinged on a weapon that was so small, it was practically invisible. We're not talking about some complicated script or a crazy vulnerability. Nope. It was just hiding right there in the code, in plain sight. I want you to really let that sink in for a second. The entire operation, compromising thousands of users, stealing a massive torrent of sensitive data, it all came down to one single line of code, buried deep on line 231. And here it is. This is the weapon. This one tiny instruction. All it did was add a blind carbon copy, a BCC, to every single email sent using the tool. And the recipient? An email address at a domain called giftshop.club. I guess the gifts were everyone's stolen data. Pretty clever, huh? Okay, so as shocking as this specific incident is, it's really just a symptom of a much, much bigger problem. This attack wasn't just a fluke. In a lot of ways, it was kind of inevitable, a consequence of a system that's just, well, fundamentally broken. All right, so I've been saying MCP server a lot. What even is that? Well, think of it like a tool that gives your AI assistant superpowers. It's what lets the AI actually do stuff in the real world for you. Send an email, run a database query, all on its own without you having to click approve every single time. And this is where the core of the problem lies. It's the God mode permissions we just hand over to these tools. We're basically giving them the master keys to the entire kingdom. We're letting them send emails with our full authority, poke around in all of our databases, and use our API credentials. We trust them completely without a second thought.
But here's the kicker. Your AI assistant? It's like a blindly obedient employee. It's built to follow orders, not to question them. It can't possibly look at that extra BCC field and go, that looks kind of shady. Nope. It just sees a command to send an email and it does its job perfectly, over and over and over, all while unknowingly being the perfect insider threat.
And the scale of this blind obedience is just staggering. When you look at the download numbers, even conservative estimates put the number of stolen emails somewhere between 3,000 and, 15,000 every single day. That is a catastrophic amount of sensitive data just flowing straight into the hands of an attacker.
Okay, so that's the problem. It's big, it's scary, I get it. But the important question now is, what can you actually do about it? So let's walk through exactly how to check for this threat and what you need to do to protect yourself.
All right, here are the forensic details, the things you need to be looking for. We call them indicators of compromise, or IOCs. First, the package name is postmark MCP from NPM. The malicious version is 1.0.16 and anything after that. And you're going to want to scan your systems for the attacker's email, fan@giftshop.club, or that C2 domain, giftshop.club. Now, if you find any of that on your systems, here is your 3-step plan. Don't wait. Step 1, uninstall that postmark MCP package immediately. Step 2, and this is absolutely critical, rotate any credentials, API keys, or passwords that could have possibly been sent in an email. Just assume they're compromised. And step 3, dig into your email logs to figure out exactly what data was sent to the attacker's domain.
And I've got one last kind of chilling detail for you. So after this whole thing was discovered, the developer just deleted the package from NPM. But here's the thing, that doesn't actually fix the problem. Not at all. Deleting it from the registry doesn't uninstall it from the machines where it's already running. That means the backdoor could still be active, still harvesting emails on compromised systems right at this very moment.
Which leaves us with one final, pretty unsettling question, doesn't it? Okay, so this backdoor was found, but when you think about how much we trust these open source tools and just how simple this attack really was, it makes you wonder, how many other backdoors just like this one are still out there, just hiding in plain sight, waiting for their moment?
As an information security professional myself, here's what I think. In the real world, the disgruntled employee is not just your only insider threat. Now, as companies are relying on more open source tools, AI agents, automation scripts, which have deep access to internal systems, and even if one of them gets compromised, it can become a silent insider. So, how do we prevent this? I think there are some key takeaways that we can ensure in our organizations. We can ensure that we verify what is being installed. We can make sure that we only use vetted or internally reviewed packages. Sometimes it's not scalable for a human to do it, but if we can have security tooling do that for us, I think nothing like that. Secondly, if there are any tools that we are using like MCPs or AI agents, we should ensure that they only have access they need, not blanket permissions. And next thing is adding visibility. Can we make sure that we log what these tools are doing? If there are any outbound actions they are taking, like sending emails or making API calls to pull sensitive data or uploading data, can we at least log the sensitive actions? Next is we can have gateways or registries, right? Just like firewalls protect our network, we can ensure that we have some kind of gateways which can protect our automation layer. And finally, let's say if an incident has occurred, we make sure that we rotate the keys, we remove the old versions, and we scan for any exfiltrated data immediately. Hopefully this blog read was helpful, and please like and subscribe to let me know that you are liking the content and would like to learn more. Till then, happy learning.